In the early 1990s, almost every scientist agreed on one thing: the expansion of the universe. In 1929, American astronomer Edwin Hubble studied supernovae, exploding stars, and from his research determined that the universe was expanding. Basically, there was the Big Bang 13.82 billion years ago, which sent all known matter flying out from a single point. Thus, the expansion of the universe began. No one had proven exactly why, but it was believed that gravity would inevitably slow the expansion of the universe as time went on. The universe is made up of matter, and gravity pulls matter together. So even though the matter was expanding from this single point, the effect of gravity had to be slowing this process over time. Of course, this had never been proven, but given what was known about how gravity works, it had to be true, right? Wrong. In 1998, the Hubble Space Telescope observed 3 distant supernovae, the most distant occurring over 7.7 billion years ago. These observations basically proved that a very long time ago, the universe had been expanding more slowly than it is today as you watch this video. Take this baseball for example. If I were to throw it up, it would come back down. That's how gravity works. But this time, pretend it's not a baseball. Pretend it's the edge of the universe. And when I throw it up, it just keeps going up at an ever-accelerating rate and getting farther and farther away. So, the universe is expanding at an ever-increasing rate. Great. But why? At the time of this discovery, in 1998, no one had an explanation. Over the past 16 years though, theorists have come up with some possible explanations. The first possibility is that a long-discarded version of Einstein's theory of gravity was actually correct, and explains this very phenomenon. This theory contains something called a cosmological constant. This cosmological constant is usually denoted by a capital lambda. Basically, this is the value of the energy density of the vacuum of space. The second possibility is that space is actually not empty, but filled with some sort of energy fluid that causes the universe's expansion to accelerate. The third possibility is that the currently accepted theory of gravity produced by Einstein is wrong. Possibly a new theory could replace this, a new theory containing some kind of field to create this cosmic acceleration. So, which is correct? To this day, we still don't know, but whatever the correct solution is, it has been given a name, though we haven't found it: dark energy. So, what is dark energy? Not much is actually known about dark energy. One thing we do know, though, is how much of it our universe contains. Scientists have been able to come up with these numbers based on how it affects the universe's expansion. Why do we care about dark energy? Well, because simply put, there's a lot of it. A lot. Normal matter, what makes up you, me, our planet, everything in the universe before the discovery of dark energy and dark matter, is referred to as normal matter. Normal matter is only the tip of the cosmic iceberg. The universe is made up of roughly 5% normal matter, 27% dark matter, we'll get to that later, and 68% dark energy. This means that there's almost 15 times more dark energy than there is normal matter. One possible explanation for dark energy comes from a pretty bright guy, Albert Einstein. Einstein was the first person to realize empty space is not nothing. Einstein realized that it is possible for more space to come into existence. The theory of gravity that he came up with, the one we talked about earlier with the cosmological constant, makes an important prediction. Empty space could possibly possess its own energy. This energy is a property of space itself, and therefore isn't diluted in space as it gets bigger. So as more space appears, more empty space energy appears with it. This creation of new energy could cause the universe to expand faster and faster over time, as has been observed. The only problem with this theory is that no one understands the cosmological constant, why it's there, or even why it has the perfect value to cause this acceleration. Another possible explanation for how space acquires this mysterious energy is derived from the quantum theory of matter. This theory says that empty space is full of temporary particles that are constantly appearing and then disappearing. Physicists tried to calculate how much energy this would give space, but the answer they came up with was off by a lot. Like 10 to the 120th times too big, so very, very wrong. Quintessence is another possible explanation. Quintessence is the name theorists have given to possible dynamical energy fluid, something filling up all of this space. The quintessence would have the opposite effect on the expansion of the universe than that of matter and normal energy. The problem with this theory is that we still don't know what it is, what it interacts with, or how it got there. The final possibility is that we have been misunderstanding gravity ever since Einstein's theory of gravity was introduced. If this possibility is correct, though, then Einstein's theory of gravity would need to be replaced with a new theory that can explain why the universe is expanding, along with many other discoveries. The problem is, a better theory has yet to be produced, and since Einstein's. Until the day when more better data is produced, dark energy will remain a mystery. So what about that other 27%? The other 27% of the universe is believed to be made up of dark matter. A lot more is known about dark matter than is known about dark energy. First, we know that it is dark. Dark in the sense that we cannot see it. Secondly, we know where it is and how to find it. It doesn't emit light like a sun, or reflect light like an apple does to red light. It can, however, be found through gravitational lensing. This is where scientists observe the way dark matter's gravitational pull bends and distorts light from distant galaxies, which emit their own light. We also know that dark matter creates the effect of attraction opposite to its cousin, dark energy, which repels. The Milky Way is shaped like a disk that is roughly 100,000 light-years across, whose stars orbit the center of the galaxy. The laws of gravity say that the stars near to the center of the galaxy should move faster than those on the edge of the galaxy. Astronomers measured this to prove their theory and found that they were wrong. All stars orbit the center of the galaxy at about the same speed. This suggested that something around the galaxy was attracting stars. Calculations show that this attraction is caused by a halo of dark matter surrounding our galaxy. This halo could possibly be up to 10 times more massive than the Milky Way, explaining its strong gravitational pull. This effect has been observed in other galaxies as well. Through these observations, we have ruled out stars, antimatter, dark clouds, or any other form of normal matter to make up this 27% of the universe. Some possible explanations for dark matter include supermassive black holes, machos, massive compact halo objects, and WIMPs, weakly interacting massive particles. Machos include brown dwarfs, a type of weak star that has a gravitational pull but doesn't emit any light. These brown dwarfs could have the gravitational effect on light that is observed through dark matter. It isn't really known how dark energy and dark matter are related, only that they both originated from the Big Bang along with everything else. They both, still to this day, remain equally mysterious, and prove that for how much mankind has discovered over the years, we still know very, very little. Keep on searching. And as always, thanks for watching.